Have you ever wondered what makes computers so incredibly powerful? Well, a huge part of it is their ability to do the same thing over and over and over again without getting tired. Today, we're going to pull back the curtain on the simple but brilliant idea that makes all that possible.
So let's just start with a simple problem. Imagine you're writing some code, and you need the computer to print a message. I don't know, something like, "Welcome to Java," 100 times. How would you actually do that?
I mean, you could just write the same line of code 100 times, but wow, that would be a nightmare. It's tedious, you're bound to make a typo, and honestly, it's just not how programming is done. It's the brute force way, and it's a huge waste of time.
Yeah, there has to be a smarter way, right? Programmers needed some kind of shortcut, a way to just say, "Hey computer, do this thing X number of times," and then just walk away.
And that smarter way is called a loop. That's the secret sauce. A loop is basically just a command in your code that repeats a block of instructions as long as a certain rule or condition is true. It's the perfect solution to our problem. So, how does a loop actually work? How does it think? To really get a handle on this, we need to break it down and look at its basic parts. It really just comes down to three key things. First, you have to give it a starting point. We call this initialization. Think of it like starting a countdown at 10. Second, you need a condition, the rule that tells the loop when to stop, like stop when you hit 0. And third, you need an update, which is how the value changes each time. For our countdown, that would be subtract 1. Start, stop, and change. That's it.
Now, there are a few different kinds of loops, but let's zoom in on one of the most common ones to see this whole thing in action, the while loop.
This little diagram here shows the logic perfectly. You can think of a while loop as a gatekeeper. It asks a question. If the answer is true, it lets you through to run some code. But then, and this is the key part, it sends you right back to the gate to ask the question again. As soon as the answer is false, the gate closes, the loop is over, and the program moves on.
You know, the best way to really understand this is to put ourselves in the computer's shoes. So let's trace a super simple piece of code and follow its logic, one step at a time.
Okay, here's our code. First, we create a variable called count, and we set its starting value, we initialize it, to 0. The rule for our loop is pretty simple. It'll keep running as long as, or while, our count variable is less than 2.
All right, here's the first check. The computer asks itself, is the value of count, which is 0, less than 2? Yep, that's true.
And because the answer was true, the computer gets to go inside the loop and run the code. In this case, it prints "Welcome to Java" on the screen. Simple enough. Now for that super important third step, the update. The code adds 1 to our count variable. So it goes from being 0 to 1. And here's the looping part. The program doesn't just continue on. It goes all the way back to the top to check the condition again. It asks, is count, which is now 1, less than 2? And the answer is yes, it's still true. So, since the condition was true again, the code inside the loop gets to run a second time. And, you guessed it, "Welcome to Java" gets printed again.
After that second run, the update happens again. The count variable increases by 1 more, so now its value is 2.
Okay, here's the big moment. The computer goes back to the top for one final check. It asks, is count, which is now 2, less than 2? And for the very first time, the answer is no. 2 is not less than 2. The condition is false. And that's the off switch. Because that condition finally became false, the loop terminates. It's done. The computer completely skips the code inside the loop and just moves on to whatever's next. And just like that, our message was printed exactly 2 times. So you can see, loops are incredibly powerful. They're basically the engine of automation in all of programming. But you know that old saying, right? With great power comes great responsibility. Now, that while loop we looked at is just one tool in the toolbox. Programmers have others, like for loops and do-while loops. But they all have one thing in common. They absolutely must have a condition that will at some point stop them. So that begs the question, what if it doesn't? What if the condition is never met? And this quote from the source material just hits the nail on the head. A programmer can write some code that looks totally fine, but it can hide a really nasty bug, an infinite loop. Take a look at this crazy example. The idea seems simple. Start a variable at 1, subtract 0.1 each time, and stop when it's exactly 0. Sounds foolproof, right? Well, here's the catch.
Computers sometimes struggle with the math for decimal numbers, so the value might go from 0.1 to something incredibly close to 0, but never land exactly on 0. It just skips right over it. And because of that, the condition to stop is never met, and that loop will just run forever, which could totally crash the program.
So what's the big takeaway here? Well, loops are the secret ingredient for automation. They make modern software possible. But you have to design them so carefully, with a clear, guaranteed way to stop.
And that kind of brings us to a fun final thought. We've seen how computers do it. Now that you get the logic behind it, think about your own life for a second. What's one boring, repetitive task you do all the time that you wish you could just hand off to a perfectly designed loop?